this video, we need to look at how to find the volume of revolutions, and this is just going to be part one, just kind of some of the basics, because this is going to address something called a washer method. There's also a disk method, and on this set of notes we're going to always start at the origin, which makes questions a little bit easier, but we'll have to talk about what happens when you're not at the origin later on in class. Okay, so if we look at this first picture here, we've got a visual of, looks like we've got some kind of curve, and shaded in, it looks like they have found the area under the curve. So with integration, we've done that many times. Well, now we're going to talk about what happens if you took that area and you rotated it a certain way, like around the x-axis. Well, that's going to create a three-dimensional shape, which would look something like our second picture here. And with the three-dimensional shape, we could be interested in finding its volume, and with a little bit of calculus, we can do that, because for this three-dimensional shape, we really just have a bunch of circles. So look at the third picture. If I can find the area of that circle, the area of this 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 circle, there's infinitely many circles there. But as long as I can find the area of all of those and total them up, then I can find the volume of our solid. Alright, so question one. Washer method, this one is going to be about the x-axis. We're going to rotate it over the x-axis. So let's try to sketch this graph. Okay, here's y equals 0, and x squared minus 3 would be a parabola shifted down 3. Okay, so the area under the curve there is that, and the point of intersections where x squared minus 3 equals 0 would be at negative square root of 3 and positive square root of 3. Okay, so now what we're going to do is we're going to say, well, let's rotate this area about the x-axis, and so my picture here is not going to do it anywhere near justice, which is why I tried to give you the picture at the front here. But it's going to look something like this. And what we really got is a bunch of circles here. Many, many circles, or washers. That's where this name comes from. So really, if I can come up with a formula to give me the area of one of those circles, and then I use calculus to total all of those up, then I would end up with the volume of that three-dimensional shape. Now, since this is about the x-axis, we will integrate, and we will use dx, and we'll use the bounds from x values. Okay, so if I want to know the area of a circle, we know that that's going to be pi r squared, and pi is just a constant, so I'm going to write that guy out here. And now radius, we can see that the radius is changing. The radius here is much bigger than the radius here. So, but the radius is always defined, or I guess I could draw it down since this is where the function is. It's always equal to this function y equals x squared minus 3. So instead of saying r, we will say x squared minus 3. Okay, so, given enough time, we should be able to integrate that by hand. If you had a calculator, you could just type all that in, get an answer. We'll practice that in class together. But ultimately, what you need to see is that this is going to add up infinite number of circles from this x value to that x value, and circles, so pi r squared. We just have to put some thought into what r is. Okay, so now I'd like you to try this one, very similar type of question, so if you go ahead and pause the video, and then unpause when you're done. Alright, so hopefully you made a picture, because that's going to help you visualize what's supposed to be going on here, and we're still rotating about the x-axis, so because of that, we are going to do dx, and we're going to look at these x values, So you need to think about where negative x squared plus 4 equals 0. That would do that. And again, we're just going to add up a bunch of washers, a bunch of circles. So you should visualize your circles. If not, try to sketch in a few of them to help you see that. And then our radius of each circle is from here to the function. So area of a circle would be pi r squared, but our r is coming from the function. Okay, so that's where that volume is going to come from. Again, given a few minutes, you should be able to integrate that by hand, and if you use the calculator, you should be able to do it quickly. Okay, we got one more thing for this video, and we're going to do the same thing, but now we're going to talk about what happens if you rotate it about the y-axis. So let's first go ahead and set up our picture here. So here's y equals 0, here's x equals 0, and y equals negative x plus 8. Okay, so the area that does is here. But how this one's different than questions 1 and 2 is we're going to rotate it about the y-axis. So now this is going to come over here, 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 here. When we rotate it, we're going to get a 3D shape that looks something like that. So we're still adding up a bunch of circles, but because this is about the y-axis, we want to write it in terms of y, so dy. And because it's in terms of y here, we need to be looking at the y values, the smallest y value I'm interested in, and the biggest y value I'm interested in, not the x. Okay, and now with my picture here, I can see that this is the radius of some of those circles. Well, notice that this length is what the x is. So I have this equation, but I want to know what x equals. So you would solve that in terms of x, and so r or x, same thing here. We got a bunch of circles, so pi r squared, and r is going to be negative y plus 8. So that integration there would give us the volume of that solid. Okay, number 4 is just like number 3, so if you would, one more time, pause the video for me, give it a shot, and then unpause when you think you're finished. Okay, so these 3 equations should look something like this, and so here's our enclosed area, and if we rotate this about the y-axis, then it's going to do something like this. Okay, and being very careful here about the y-axis, we want dy, and our limits of integration are going to come from the y values, the smallest y value to the biggest y value. Now it's still a bunch of circles, so it's still going to be pi r squared, and with your picture here, hopefully you can try to visualize what r is. So this is r, but it's also x. So if y equals x minus 5, then y plus 5 equals x. So that's your radius. Depending on your y value is going to change what the radius is. So instead of r, we should put y plus 5. Okay, and that integration, if solved, would give you the volume for that. Okay, so if you feel like you need to practice doing these by hand, feel free to go back and do that. Check with the calculator if you need to, and then we'll talk about the other methods in class next week.